All right, thank you so much for attending Hear from Peers for the webinar series for the fall. Today we will have Dr. Hardy to share about his works with the, I believe this one with the ITF, which is Innovative Teaching Fellows from Center for Teaching Excellence. He will present to us about formative assessment with generative AI, and I will give the floor to Dr. Hardin. Thank you so much.
Thank you, Armando. Hi, I'm Bobby Harden. Like I said, I'm going to be talking about formative assessment with generative AI. Um, I want to go ahead and acknowledge, so this was part of the Innovative Teaching Fellows with AI program through CTE, and our graduate assistant, JD Radadaya, who helped with this project, as well as the consultant there, Kelly Adams. All right, so I've got a quick survey. Just I like for everyone, if you can, to just go ahead and briefly scan that code or go to that link. It's probably much easier to scan the code. And it's just a quick survey about generative AI use. I don't have a lot in the audience, but I'll give you a chance to do that, just to start thinking.
Can I ask, in the survey, knowledge means you know it exists, right? Or you know how it works, or you know how to do one.
Yes.
What was the right one?
Excuse me?
The first question is to rate our knowledge of generative AI tools.
Yes.
Be aware of the tools or know how it works or know how to create one.
Yes. So really just awareness. So it's a kind of a basic level of knowledge in terms of, and how it works, not necessarily the level of creation, but as most faculty would use it day to day. Again, it's not very scientific, so just looking for feedback, right? So well, if everyone had a chance to scan that, I'm going to move on with this. And again, realizing that we may have a wide variety in the audience, we'll establish some basic kind of definitions here. This is a nicer figure than I've used in my class. My background, I do work a lot with data and have worked with machine learning for some time on the research side. So these are kind of basic models and a lot with computer vision in recent years. But how we define generative AI is really starting under the broad umbrella of artificial intelligence, which is really trying to build computers that act like humans or maybe act rationally, which humans don't always do. As we kind of narrow down the circles there, we go into machine learning, where we want computers to learn from data. That's really the key aspect of machine learning and the deep learning in generative AI. We're taking large amounts of data, learning patterns from that. Deep learning, and this includes a lot of the computer vision work that's been done recently. So if you have experience with that, or if you see anything like self-driving cars, right? There's a lot of vision capabilities that are involved there. We're using what are known as deep learning models. They're essentially like basic machine learning neural network models. They have multiple hidden layers. So they do more complex tasks because they can abstract features down at multiple levels. And finally, the newest one there in the smallest bubble is the generative AI. And so these are considered models that generate new text, audio, images, video, computer code. It's a great tool for programming. There are some challenges with that. One, is it really ever generating something novel in the sense that we use as researchers or as an artist might, or is it just combining features of other things? And that's a bit of a semantic question. But when we're talking about generative AI and its common use, we're looking at things that are creating new content. And commonly, these are large language models like GPT, and where most of us are familiar with ChatGPT, which was released a few years ago and is now on version 5. This is a recent survey. I think it's instructive for our discussion here today. Who's using this, right? Well, there's a lot to unpack in this figure. Kind of the key take-home message is, of course, the darker colors indicate frequent usage versus the lighter ones being lower usage levels. If we look who's using it the most frequently, or the occasional use of monthly, it's students and administrators now. The administrators have caught up quickly. So we know our students are using it. I find that instructive that administrators are using it. One of the tasks that I find it most useful for are kind of administrative things, right? A lot of what we do as instructors when we're talking about kind of the core functions of teaching in our research, I don't think it does a very good job of that at this point, but which is probably good for our job security. But certainly administrative tasks we can delegate to an AI as a kind of a knowledgeable assistant. And our students are using it in various ways. This can include everything from developing study aids to asking for additional explanation of difficult material, to just writing papers. So there's a variety of uses there. And so, what's kind of the take, right? So I like this 2 articles out of the Chronicle of Higher Education within a few months or a few weeks even. So this first one, in the age of AI, is education just an illusion? And it, of course, gets to the kind of, I guess, doomsday scenario where we have a student that turns in an AI-generated paper. The instructor uses AI to grade it, and so we have AI evaluating AI. Well, there's no actual learning going on. But a couple weeks later, are you ready for the AI university? So where do we use this? Where do these tools fit in? And so that's kind of my goal today, is to really highlight a potential use of this that I hope doesn't, we don't want to eliminate the human interaction of teaching and learning, but something that can help us as instructors be more efficient and provide better feedback to our students. And a brief overview, I think a lot of people are familiar with this, but I'm happy to share it and kind of spread the word on some of this if you're not, is that through Texas A&M University, we have access to several tools for generative AI. So you can follow the link there to the AI services on the IT page on technology services. And then some of the examples, right? We have access to Copilot through Google Gemini and Notebook LM. And then most recently, the Chat AI platform that A&M, the system, has put out. So in my work, I've used Copilot. It was out there first. There's some real limitations for what I want to do with that. So we kind of have moved into trying to use the Chat AI platform. So with that, I'll stop. Does anyone have any questions? And I need a drink of water. Get over cold here.
No.
All right, so a little bit about my project. So what's my motivation for this, right? So one thing I've observed, so I teach in biological and agricultural engineering. I also teach some courses in our technology management program. So it's not an engineering program, but a technical management major, combining kind of business and technology classes. One, it's hard to know for me when students are struggling. Like many instructors, like we give homework that essentially are very much practice problems for an exam. We have lab assignments, but those all take some time to grade. So in the meantime, students are falling behind. They don't understand things, and I can see where some of them struggle, but I don't necessarily have great tools for addressing that. One, because like all faculty, my time is very limited. And particularly lately, I've been teaching an extra class. All my classes have labs. Most of the classes are fairly large, 50 to 60 students. Now, I do have TAs and graders to assist with that. But even then, there's not a lot of time left to grade additional assignments or provide some detailed feedback. So really the goal of this is to see if some of the generative AI tools, specifically the large language models that like ChatGPT and others, can address these problems. And you notice my AI generated image there, which does have some misspellings, is some earlier versions of generated images were prone to do. But it's really illustrating this illusion of learning. Students don't really know enough to assess the status of their knowledge. And it's hard for the instructors to assess this for the factors that I mentioned, just the delay time, the time available to read student work and give feedback. Well, the tool for this that we typically use is formative assessment. It's also known as assessment for learning. Now, the key feature of this is really giving precise, timely feedback, which, as I just mentioned, is a really challenging thing to do, particularly for a lot of us with heavy course loads and many students. And it's because it's really time consuming to do it well. We also don't use it much in engineering. Because we use summative assessment, right? So I need to make sure my students can solve engineering problems. So I can't just give them formative assessment questions asking for them to describe something. There's a place for that, but in engineering, we have to do the summative assessment as well. In some disciplines, we can see more formative assessment because that's there's not that need to solve a technical problem. And research has shown that formative assessments are an essential part of a classroom optimized for learning. One thing it does do is it helps the students develop self-assessment skills, and that's really one of the goals that I want to achieve by implementing this, is that students are able to monitor their own progress and say, well, I need to review this topic some more, need to work some more problems, and need to go talk to the instructor and get some additional help. Some kind of specifics related to engineering. There's been some really recent use of LLMs for feedback in some different STEM fields. It's pretty limited, and there's some challenges with doing that. Going back a little further in the literature, in the engineering education literature, there's some techniques that are promising for applying through the use of LLMs. In particular, if you describe a strategy for solving a problem, and instructors have often used this on a test. They might look for a correct answer, but will also get points based on if you can correctly state the methods for doing that. And there's an important pedagogical reason why. So experts tend to describe the key principles and the methods. If you ask a novice that's just learning about it, they tend to list facts, and they might not be related in any meaningful way or connected in some logical manner. Now, I'm very much focused on the classes I teach and the specific applications there, but I suspect there are critical questions like this in other fields. And specifically defining this problem for developing formative assessment is probably important for coming up with useful output from a generative AI model. So just a general overview of the process that we're going through in this ITF project is really we're starting with some input documents. Kind of a good practice in prompt engineering of large language models is providing some reference text. And this helps constrain the problem So for the course I'm using, I simply use my lecture notes. There may be other things other instructors would want to use. These could be, online text, other resources, any other course materials. That's a way to constrain that problem. As I said, we're also got a specific structure to our assessment question. I'm looking for a specific type of problem. It fits the class I'm teaching well. And so it helps to generate good assessment questions. Now, it's important to note that at each stage of this, so we generate assessment questions, it's not a, complete automated process where there's no instructor interaction. I think that would be probably unwise and really not doing my job as a teacher. So in this case, I read through them, and generally will provide multiple options, and I'd select the best ones. And I really didn't have to modify much from that. I also used it to generate solutions so far. And again, it required a little bit of prompt engineering, and I'm reviewing those for accuracy. The challenging part, we're just now starting to evaluate this, is evaluating and generating feedback to the students. That's, of course, the hard part. That's the part that takes the most time. And I'll explain a little bit more, why it's taken a little while to get to this point. So what I did was in the spring, I evaluated kind of these methods in a junior level course on measurement sensors and control. It's one where there's some very technical topics that get introduced in the beginning of the course, and then we look at some applications later on. It really depends on some prerequisite courses the students have had. It builds on those. In some cases, the students really don't show a high level of mastery from those. So it's a challenging course to teach and make sure that everybody gets to the level they need to be in that course. As I said, when we started in the spring, Microsoft Copilot was the best solution for doing this. It's not probably the best, but it's what we had in the start of the spring semester. I input in the lecture slides. I said, I asked for descriptions of those problem-solving strategies. Select the one or two best out of 6 to 8 proposed, and sometimes did some combination or minor editing of those. And how I evaluated, I assigned this on Canvas as part of the attendance grade. So I wanted students to do the assessment questions, but I didn't really want a high stakes assessment. I wasn't evaluating to see what the quality of their answer was. Basically, I told the students, as long as they give me a non-trivial answer, they get credit. So I wanted them to do it, provide the feedback for me to use, and also in answering the question, they'd get the solution. So hopefully that helps them with some self-assessment. And then I looked just how the 2024 and 2025 cohorts did on their exam questions. But that's a pretty small sample size, I admit, but we'll take a look at that. So just as an example of the prompts, I've got some more details at the end of the slide set on prompt engineering if anybody's interested, but in general, you want to be specific. Identify what your role is here as an instructor. I'm providing the reference text, with Copilot or the Tamu Chat AI platform. You can upload files. So I tell what that file is. It's a lecture on this topic. And then my specific question about designing the formative assessment. And then in terms of generating a solution, I asked it to provide sample answers. And then usually I found those to be kind of lacking some detail, but it generally, in asking for more detailed explanations, it did a good job of providing that. Not always. As I said, I usually had about 6 to 8 questions for each lecture. So I eliminated the ones that did not really provide comprehensive assessment question or solutions that really met my standards. So just in providing these assessment questions, which the students could use really for self-assessment, I did find that, especially on the first 2 exams, my students scored significantly higher across all the questions. I was about 15 points higher on the 2 exams. And I did actually run this through SAS, so it's statistically significant, those differences, through the first 2 exams and on all the conceptual type questions I ask on those exams. Exam 3 is a little worse in 2025. You know, it's hard to assign factors with just one cohort of students. One thing that did jump out was that whereas I have some students that were typically in danger of not passing the class in previous years, I really had no students that fell in that category in 2025. So in that sense, perhaps they just weren't as motivated on exam 3. They are about half the class are graduating seniors. If they don't need to do well, they probably had other priorities. But you know, small sample size, so I'm not going to make too many conclusions about that. One thing that was a big challenge in this project so far is integrating Microsoft Copilot and Canvas. It actually would have been easier for me to just write questions and put them in Canvas. You know, the point of me experiencing this pain is to try and develop some methods to help others here, you know, on campus, you know, do this. I think the new Tamu AI chat, which everyone has access to now, offers a potential solution. You know, so this is kind of putting it into the chat. One thing we want to do in this project is kind of compare some of the different models. And there's some differences. Basically, some end up being a lot more verbose. Some of the new reasoning models, if you're trying to explain an answer, they tend to do a little better with that. So we see some differences. And there's probably some models are better for certain applications. So what I want to do in the future is really automate this, right? That right now it's not saving anybody time. The AI chat platform, and this gets a little technical here, uses the open web UI platform to deploy those large language models. And there is API access. You can use Python. That's what I've used, you know, is doing scientific and technical coding. You know, it's kind of the language we've used lately. That's what I'm using to try and access this. So it's kind of just a snippet there of how you can access some code with that. I'm not really getting into addressing the student responses and providing feedback yet, but essentially we have a method and a framework for doing that now. You know, we input, you know, those the student assignments. You can download them from Canvas. One challenge is to make sure they're in a format that is easily ingested by, you know, by Python and the large language model. Then we can generate feedback and upload. And really, we want to automate this all, and it's pretty easy to develop, you know, a simple graphical user interface. You know, all it would take then is the user to specify prompts, input materials, and then, you know, to get the feedback, you know, download your assignments out of Canvas, and then hopefully get those uploaded back in. So the idea, the long-term vision is to make this very much automated, where it's really the instructor provides oversight. You know, in this step, you know, you're going to tell it what model to use. It's going to generate at least a first draft of feedback, and then you can edit that later. You know, I know there's some tools to do this within like Canvas, or at least some more large language models that people have used. I'm not sure that any provide quite this functionality. We also want to make it platform agnostic. Anybody that's been here a while knows that we switch learning management systems periodically, and you know, we don't want all our tools to stop working and have to learn new software. So if we can build something simple that's pretty flexible, then I think that's a benefit. So just a little bit of, you know, folks want to share this. You know, I do like to give a plug for the CTE Gen AI initiative, since we've been working with this. There's another, you know, obviously this is the Hear from Peers workshop, but there's other workshops in learning communities and other opportunities there. So if anyone has questions, now's a good time. I'm happy to entertain whatever discussion we want for the remainder of our time. I've got some suggestion topics if we need that, but folks have questions, I'm happy to answer.
All right, thank you, Dr. Hardin. I will stop the recording.